Hello, algebra students. Today we have a very important lesson, and this lesson is going to be factoring still, but now of the form ax squared plus bx plus c. Up until this point, everything that we factored has started out with x squared plus bx plus c, or there's been a 1 as our first coefficient, as our leading coefficient. Today, we are going to be factoring problems where there is a number here, and we refer to that number as a. This is going to drastically change the process for which factoring is going to happen. We no longer can just look at the c term and find the factors of c that get us to b, like we have been doing. We're going to have to do something very different, and this is going to be an important lesson and also a moderately difficult lesson. So let's dive into it. Actually, before we do, let's look at the old type of factoring. This is still going to be useful, but you are specifically going to say, hey, this doesn't have a number in front of the x squared. Therefore, I can go to the last term and list the factors of that last term. The factors of 12 are just 1 and 12, 2 and 6, and 3 and 4. Now, which of these factors could potentially add or subtract to the middle term, which is 4, and that would be 6 and 2, if the 2 was negative and the 6 was positive. So then this factors into x minus 2 and x plus 6. As I stated, the process when there's a number in front of the x squared is what we're studying today, and that process is completely different if there's a number in front of the x squared. I teach something very different from what the book teaches. You are welcome to use this book's method. The book uses a table. You will be able to find the table when you look at example 3, or actually any of the examples, but they go through this process and they make a table and they find the right answer. I use something that I'm going to refer to as the box method. So whenever you hear me talk about, hey, you have to use the box method on that problem, this is going to be what I'm referring to. I do have a guided notes worksheet available on Schoology. Please take a second to grab that. It's going to have the 6 examples that we're going to do today and these directions on it already. So step 1 says to create the box that looks like this. It's going to have x squared in the first box. I'm going to refer to this box as the first box. And then the second and third box have x's in them, and the last box doesn't have any x or any variable. Step 2 says to place a. A is the thing in front of x squared in the first box, and c, the thing that doesn't have an x, in the last box. Then multiply those two numbers together and write it outside the box. I'm always going to write it right after the box, like right there. And then, much like over here we listed the factors of 12, when we are doing the box method variety, remember the box method is when there's a number in front of x squared, this is the number you're going to be looking for the factors of. List the factors of the new number, this number right here. And you are going to still find the factors that get you to your middle term, the b term. So we've listed some factors, numbers. We say, hey, these ones get you to the middle term. And those are the two numbers that are going to go in the second and third boxes. And the order in which you put them, whichever one goes here and here, they're interchangeable. And then these last 2 steps are pretty weird. You are going to identify the greatest common factor of the top 2 boxes and write that factor here. That's step 6. And then step 7 says complete the rest like a multiplication table. And you guys should know multiplication tables, at least the gist of them. They're like, hey, 1, 2, 3, 4, 1, 2, 3. And then you can follow the row and column, and you're like, hey, there's a 6 here because 3 times 2 is 6. And you know, it would be all filled out like this, 1, 2, 3, 4. You could be like, hey, 4 times 3 is 12. And you just follow the column down and follow the row over, and you get to your answer. So that's a multiplication table, right? This is going to be kind of like that, except we already know what's inside the box. We're going to be filling out what's on the outsides. And so that's kind of a challenge. But once you get that, the answers are going to be whatever's up here in parentheses and whatever's over here in parentheses. We're going to go through 6 of these examples. It's going to be a decent amount of work. These are not necessarily easy problems. So hopefully you guys are kind of understanding, but if you're not yet, that's okay. We haven't even done an example yet. So step 1 says to create the box that looks like that. Here's the box. Step 2 says to place A. A is the thing in front of x squared in the first box, and C, the thing that's at the end in the last box. Step 3 says to multiply the A and the C and write that number outside of the box. So 2 times 3 is 6. I'm going to write 6 here. And then step 4 says to list the factors of that new number, 1 and 6, and 2 and 3. And you're going to select which of these factors could get you to your middle term. Our middle term is -7. And so if we want 1 and 6 or 2 and 3 to get to -7, of course, that would be -1 and -6. Right? -1 and -6 get you to -7. So those two numbers are going to go here in this box and here in this box. It doesn't matter the order in which you write these. You could have flipped them. It would give you the exact same answer at the end. So here's step 6. Step 6 says to identify the greatest common factor of the top two boxes. So we have 2x squared and -6x. The greatest common factor of 2 and -6 is 2. We've been practicing finding the greatest common factor lately. So hopefully you guys remember that the factors of 2 are 1 and 2, and the factors of 6 are 1, 2, 3, and 6. So the greatest one they have in common is 2. And then in addition, this one has 2 x's with it, x times x, and this one has 1x. So in common, they have a single x. So 2x is our greatest common factor of the top two boxes. That's step 6. And then step 7 says to complete the rest like a multiplication table. And what I mean by that is if you follow the row in the column, it should give you what's in the box. So my question that I'm asking would be 2x times what, and that's going to go right here, would give me 2x squared. So 2 times 1 would give me the 2, right? And x times what would give you x squared? That would be 1x, or we often just write 1x as x. You guys should be able to confirm this with me. Is 2x times 1x 2x squared? It is. I should be able to follow the column down and the row over and get this as my answer. We should be able to do the same thing over here. 2x times what goes right here is -6x. So 2 times -3 would give me the -6, and x times just x. We already have the 1x we need, so we don't need to put an x here. So we already have the single x. So is 2x times -3 -6x? It is. Now I can do the same thing following this column down by whatever needs to be written here. 1x times what is -1x? That would be -1. 1x times -1 is -1x. And then we have this nice little check that will help us see if we got the right answer. And that is to say, does this column in this row multiply to +3 in this case? And it does, right? -1 times -3 is +3. So my answers in parentheses are going to be this, 1x minus 3, or x minus 3, right? And this in parentheses. And once again, the order doesn't matter, but that would be our answer. Let's do another one. We have 5 more to do. You guys will get quick at this process, but it does take a while at first. Create the box, place A in the first box and C in the last box, and then multiply those. That's step 3, and write that answer somewhere outside the box. Step 4 says to list the factors, 1 and 15, and 3 and 5. Step 4, we have to finish step 4. Circle the ones that add to B. So how could I get either 1 and 15 or 3 and 5 to add to +14? Well, if the 15 is positive and the 1 is negative, now these things multiply to -15 and add to +14. So these are going to go in these two boxes, and the order in which I write them does not matter. Now, step 6, identify the greatest common factor of the top two boxes. These guys right here. What's the greatest common factor of 3x squared and 15x? Hopefully you guys are agreeing with me that that would be 3 for the greatest common factor of 3 and 15. And the greatest common factor of x squared and x would be a single x. This one had 2 x's, this one had 1. So in common, they have 1. And then we complete the rest like a multiplication table. So the question I'm asking myself is 3x times what? 3x squared. I already have, I know 3 times 1 is 3, so that part's good. X times what is x squared? That would be a single x. X times x is that x squared. Moving on, I have the rest to complete, so I need this one to be filled in and this one to be filled in. 3x times what is 15x? That would be a positive 5. 3 times 5 is the 15. We have 1x here, and there's only going to be one total x, so we don't need to put an additional x up there. Now 1x times what is negative 1x? That would be negative 1, and 5 times negative 1 is negative 5. So my answer in parentheses is x plus 5 and 3x minus 1. Yay! Once again, the order in which I write these doesn't matter. These could be flipped. 4 more examples. This one, if you notice on my little guided note sheet, it says to solve it. The indication that you want to solve it is that it's going to be set equal to 0. So it's just going to be one more step at the end. Start out by putting A in the first box and C in the last box. We get 4 and 5 there. Multiply those, you get 20, and then list the factors of 20. That would be 1 and 20, 2 and 10, and 4 and 5. Now, which of these factors could get you to the middle term, which is negative 9? 1 and 20 never could, 2 and 10 never could, but if the 4 and the 5 were both negative, then these get you to negative 9. The order in which I write these in box 2 and 3 does not matter. We'll put a negative 4x there and a negative 5x there. And now we identify the greatest common factor of the top 2 boxes. The greatest common factor of 4x squared and negative 4x would be 4x. And now you're going to ask yourself, right, we're going to complete the rest like a multiplication table. 4x times what is 4x squared? Well, 4 times what is 4? That would just be 1. And then x times what is x squared? That would be x. You guys should agree with me that 4x times 1x is 4x squared. 4x times what is negative 4x? That would be negative 1. And 1x times what is negative 5x? That would be negative 5. And then do the little check here. Is negative 1 times negative 5? 5, it is. So my factors, remember this question didn't say to factor it, it said to solve it, but my factors would be x minus 1, or 1x minus 1 if you had that, and 4x minus 5. Now remember, this says to solve it, and it says it's equal to 0. So what the question really wanted to know at the beginning of the question was, what numbers could you plug in for x here and here, that when you do that, you get 0 out? And the process that we're using to get that answer is to factor it. And then we had this little trick, and that trick was the zero product property. It said if you have something, A, and you multiply it by something else, B, and we get 0, then either A must have been 0 or B must have been 0. And we can figure out what makes A 0 pretty easily. What number would you plug in for that x to make this whole parenthesis 0? What number, when you subtract 1 from it, do you get 0 out? And that would be the number 1. 1 minus 1 is 0, right? This set of parentheses is a little bit more challenging. It's difficult to figure out what makes this parenthesis 0. And if that's the case, just set it equal to 0 and solve it. I want to know what makes this 0. I can just set it equal to 0 and then solve for x. So you're going to add 5 to both sides, and then divide by 4, and you get x is equal to 5/4 or 1.25. I would accept either of those answers. And so these problems are going to have 2 answers, one from the first parenthesis and one from the second parenthesis. Figure out what makes them 0, and that's your answers. 3 more examples. We can do it. This one is a little bit odd in that you're going to notice that the first term is negative. The A term is negative. We do not like our A term to be negative. And so what we're going to do in these problems is actually factor out a negative 1 right away. And so what that looks like, remember, factoring out is undoing the distributive property. So if you ever see that your first term is negative, write a -1 out front, and then everything in the parentheses is going to have its sign flipped. So it's not going to be -4x squared anymore. It's going to be positive 4x squared. It's not going to be positive 12x anymore. It's going to be negative 12x. And it's not going to be positive 7 anymore. It's going to be -7. If you guys are doing some critical thinking, it's worth noting that you should be able to distribute this -1 back in to everything and get back to where you started. And we could absolutely do that, right? -1 times 4x squared is this, -1 times -12x is this, and -1 times -7 is this. So that's how I know I did an okay mathematical thing to do, by factoring out that -1. And now we're going to kind of disregard the -1. It's still going to have a -1 in my final answer. It's going to look like this, or a -1 or just a negative sign. They're both the same. But that's going to be the effect of that negative sign. We're now going to be factoring this statement. So 4 is going to go in the first box, and -7 is going to go in the last box. We're then going to multiply 4 and -7 and get -28 and list the factors of -28, 1 and 28, 2 and 14, and 4 and 7. We are looking for which factors could get us to -12. And that would be the -14 and the +2. And so those two things are going to go in these two boxes. And remember, the order doesn't matter. So I'll just put the 2x here and the -14 there. Now we get to play the factor out the greatest common factor game. Look at the first two boxes and figure out what's common between 4x squared and 2x. That's the worst 2 I've ever written, but let's pretend it didn't happen. 4x squared and 2x, the greatest common factor would be 2x. And then 2x times whatever goes here is going to be 4x squared, and that also would be 2x. You guys should agree with me that 2x times 2x is 4x squared, because the 2 times 2 is 4, and x times x is x squared. Now you're going to ask 2x times what is 2x? That would just be 1. And then 2x times what goes here is -14x, and that would be -7, right? 2 times -7 is -14, and x, we already have the 1x there. We don't need it anymore because we only want 1. Is 1 times -7 -7? It is. So my factors are going to be 2x plus 1 and 2x minus 7. And that whole thing is our final answer. We have 2 problems left. We get to have another one that starts out with a negative sign, only my example in the guided notes has that equals 0 and says to solve it. Remember, the only difference that makes is that at the end, we're going to figure out what makes the parentheses 0. So right away, let's factor out the negative sign. In the future, we're actually going to learn to factor out the greatest common factor, which is -2. If you factor out a -2, you're also going to be at the right answer. But let's just go ahead and factor out a negative sign for now, -1. If we factor out a -1, remember the sign of everything in the parentheses will change. So this would be 12x squared minus 22x. Oof, getting carried away. Minus 22x plus 8 equals 0. So the first number, 12x squared, goes in the first box, and the 8 goes in the last box, and then we're going to multiply those things. And 12 times 8 is 96. And then you're going to list the factors of 96. What multiplies to 96? Of course, we've got 1 in 96. And we've got 2 in 48. And we've got 3, and I've got my calculator here. 96 divided by 3 would give us 32. 96 divided by 4 would give us 24. There's a lot of them. 5 will not divide 96 evenly, but 96 divided by 6 would give us 16. 96 divided by 7 will not work. 96 divided by 8 is 12. And that's our last factor. So the question is, which of these would get us to -22? 8 and 12 never could, but 6 and 16 could, right? This one wouldn't. Yeah, none of these would. If they're both negative, then our numbers multiply to 96 and add to negative 22. So it's going to be a negative 6x and a negative 16x. Greatest common factor of 12x squared and negative 6x would actually just be 6x. And 6x times what is 12x squared? That would be 2x. 6 times 2 is 12, and x times x squared. X times x is x squared. Now 6x times what is negative 6x? That would be negative 1. And 2x times what is negative 16? That would be negative 8. Is negative 1 times negative 8 8? It absolutely is. So my factors are going to be 2x minus 1 and 6x minus 8. Remember, it had that negative sign or the negative 1. You can write it as either one. Currently, we have a zero product property problem. Remember, the zero product property says that if you have something and you multiply it by something else, even if you multiply it by something else, we have three things that are being multiplied, and any of them are 0, then that will work, right? Then their product will be 0. And so we need to figure out what makes each of these 0. Well, there's no way to make the number negative 1 0. There's no x here, so this is always just negative 1. There's no additional answer that negative 1 is going to give us. But we can figure out what makes this one 0, and we can figure out what makes this one 0 by just setting them equal to 0 and solving them. Add 1 to both sides, and then divide by 2. We get x is equal to 1/2. And over here, we're going to add 8 to both sides, and then divide by 6. That's actually going to give us 4/3 when we reduce it, or 1.3 repeating. And so both of these two are our final answers for our fifth problem. We've got one more, and I just thought I'd throw one here where it's missing its b term, right? The b term is not there. It still has the a term because it still has an x squared. It still has the c term because it still has one that doesn't have an x. But the process here is going to be the same. You're going to create the box. The 4 goes in the first box, and the 16 goes in the last box. You'd then multiply, actually it's negative 16. You'd multiply these things, and you'd get negative 64, and then you'd list the factors of 64. 1 and 64, 2 and 32. 3 doesn't work. 4 and 16. 5 doesn't work. 6 doesn't work. 7 doesn't work, and 8 and 8. Now you look for which factors get you to your middle term, and this is the weird part, right? Our middle term, it doesn't have a middle term, which means its middle term is 0. That's what, like if it was 1, it would still have a plus 1x here. But the middle term is 0, so which of these pairs could get you to 0? And actually, if the 8 was positive and negative, then it would add to 0 and multiply to negative 64. So in one of the boxes, we're going to have an 8x, and in one of them, we're going to have a negative 8x. Now we play our little fun game. Greatest common factor of the first two boxes would be 4x. And 4x times what is 4x squared? That would be 1x. And then 4x times what would be 8x? That would be 2. And 1x times what would be negative 8? That would be negative 8. And is 2 times negative 8, negative 16. So our answer here is going to be 1x plus 2, or x plus 2, and 4x minus 8. Now, we're eventually going to learn a different answer for this slightly, but I would accept this answer for the time being. If you guys have any questions, please let me know. This has been factoring when our a term is not 1. Thanks, guys.